Welcome back. We're working on approximating the area under this curve. And what we've done so far is we've approximated it using a giant rectangle that's too big. What we're going to do next is refine our approximation by splitting our rectangle up into two. And here's what I mean by that. So I go up to the function at x equals 1, and then I start going across to make a rectangle. But instead of going all the way across, I'm only going to go over halfway. And then I start a new rectangle by going to the function value at x equals 4, in other words, where the other rectangle left off, and I'm going to go across from there. Let's see, and I want to go to 7. So I'm going to have two rectangles like this. We're going to add up those two areas, and that will be our next approximation of the area. And I think you can see just from looking at them that they mimic the area we want better than what we did with just one rectangle. So here we go, our new area approximation. And since we're using two rectangles, I'm going to call that R sub 2. What's it going to be? Well, that first blue rectangle now has width 3. The height is still the function height at 1. And then I add on the area of the shorter green rectangle. Its width is also 3. What's the height? Well, it's whatever the function value is at 4. So coming across, the height is going to be f of 4. Just like the height of our taller rectangle is f of 1. So doing this computation, I'm going to have 3 times f of 1, but we already computed f of 1 as 4.2, so I don't need to go through that again. And then I'm going to have plus 3 times f of 4, and f of 4 will be 1/5 times 4 squared minus 2 times 4 plus 6. So that's going to be 3 times 4.2 plus 3 times, I'm getting 1.2 for f of 4. So the area of the blue rectangle is 12.6. The area of the green rectangle is 3.6. And adding those up, we get 16.2. So again, that's our approximation of the area under the curve, and it's a better approximation than the one we did before. Now, since by using two rectangles we were able to stick more closely to the region we wanted than we were just using one, let's try using 3 rectangles and get an even better approximation. So I'm going to continue going up to the function curve where x equals 1 and going levelly across from there, but this time I'm only going 1/3 of the way across. And then where I left off at x equals 3, I go to the function, go across, go 1/3 of the way across, so to 5. And then where I left off with that rectangle, I go to the function height, go across to 7. So the heights of our rectangles are f of 1, f of 3, and f of 5. So our new approximation of the area, which I'm going to call R sub 3, is going to be the width of the first rectangle, which is 2, times its height, f of 1, plus the width of the next rectangle, which again is 2. Its height is f of 3. And last, the third rectangle, width 2, and height is f of 5. As before, f of 1 is 4.2. And I hope it's okay, but I'm not going to show you plugging into the function formula with 3 and 5. I'm hoping you're okay checking me on that or duplicating it yourself if you need to. But for f of 3, I'm getting 1.8. And for f of 5, I'm getting 1. So those total up to 14. So that's our still better approximation of the area that we want under the curve. By the way, these sums are called Riemann sums. So this is a Riemann sum. And this is a Riemann sum. These are named after a famous mathematician in history. I don't know if he was really the one that invented this stuff. You can never tell with names, but anyway, they're named after him. And the idea is that if we kept taking more and more rectangles, skinnier and skinnier ones, we would get better and better approximations of the region that we actually are interested in. Let me show you what that looks like. Here's our graph with one rectangle. Now we have 2 rectangles. Then we went to 3 rectangles. Here's what 4 looks like. 5 rectangles. 6 rectangles. Let's animate it. This is 15 rectangles. This is 34 rectangles. 60 rectangles. 80 rectangles. So clearly, as we increase the number of rectangles, that green shaded area gets to be more and more and more like the region that we actually want the area of. No matter how many rectangles we have, though, we're always going to have that jaggedy line on top. In other words, the rectangles are never going to perfectly map to the region we actually want. To deal with this, we're going to take the limit as the number of rectangles goes to infinity. That's actually a good thing, though, because that is going to make our life easier, not harder.